All right, guys, so what I wanted to do here is basically give you a little guide on how you can fix some of the questions when you guys are doing your corrections. So whichever ones you got wrong, just, skip around, go right to just one particular one, or you can watch all the way through as a review for your retest, whatever you want to use this for. Hopefully it's helpful. So what I did is I have the exact same format of what the original test was. It's the exact same format of what the makeup test is going to be. And then obviously I went through and I changed your actual test problems to different problems, but the process of how you're doing these problems is still going to be the same. So we're graphing this function right here using axis of symmetry, vertex, and y-intercept. So let's start with the axis of symmetry. That's going to be that dotted vertical line, and the formula is negative b over 2a. So that's one that hopefully you guys should have memorized. So negative b would be the opposite of this middle number right here. So that would come back as positive 4, and then 2 times a would be doubling this number right here. So that is 4. So this comes out as 1. So that is going to be a dotted line right through x equals 1. Next, I have my vertex. I know my vertex is going to be somewhere on this line. So what I do for my vertex is I figure out what the y value would be, knowing that the x value is 1. So, because it's going to be an x value of 1 somewhere on this line right here. So just plug it into the original function, and then we can solve for what the y value would be. Okay, so careful with this. Make sure you square the 1 first before you multiply by 2. So 1 squared would be 1, times 2 would be 2, and then minus 4 plus 3. So this ends up being 1. So your vertex would be the ordered pair 1, 1. So that would be a point right here. Next would be your y-intercepts. And for the y-intercepts, you always know for sure that the x-coordinate is going to be 0. And if you plug in 0 for x and 0 for y, that just leaves you with 3. Okay, so 0, 3 would be this point right here. And then remember your third point by doing a mirror image of this point over the dotted line. So whatever point you have over here, you can mirror it on the other side of the dotted line. And then just go ahead and connect the dots, and you've got your graph. So we did the graph. Next would be the domain and range. Domain is always all reals, no matter what parabola you're graphing. And then the range is based on either your lowest value or your highest value here. So here, this lowest possible y value is 1, and then it only goes up from there. So we would say y could be anything greater than or equal to that lowest value of 1. If the graph is flipped upside down, then it would be less than or equal to whatever the maximum value is. All right, so that's the first type of problem. Second type, you're going to be using the graph of this function right here to solve this equation. So graphing it is going to be basically what we just did with number 1. So let's run through that again. So my axis of symmetry is going to be negative b over 2a. So opposite of b would be 4. Doubling this value right here would be 2. So that comes out to be 2. So that's going to be your axis of symmetry. We'll start with that. And then your vertex, we know it's going to be somewhere on that line. So just like we did up here, we're going to plug 2 into this equation to figure out what the y value would be. So if I do 2 squared, that would be 4, minus 4 times 2 would be 8, and then plus 2. So this comes out to be negative 2. So that's going to be my vertex. It's going to be down here with a y-coordinate of negative 2. All right, next, I do my y-intercepts, and we, again, know that we always have 0 as an x-coordinate for our y-intercepts. And if I plug in just 0, 0, I'm left with 2. Okay, so that would be this point right here, and then you can do a mirror image of that point on the other side of the line to make sure it is actually a mirror image. Since this is 2 units away, you'd go another 2 units away so that symmetry holds. So now we know we're going to connect the dots. When I tell you to solve, so like if on your test I circled the word solve and took off points, that means you didn't actually solve. You didn't actually answer the question that you were supposed to be answering. So what you're supposed to be answering is where are the x-intercepts, essentially. So like when we set this equal to 0, that means we're plugging in 0 for y. And if we're plugging in 0 for y, that means we're looking for x-intercepts. So we set this up, we want to know exactly where it's going to cross through the x-axis, and when you connect here, it'll be somewhere between 0 and 2, and then again somewhere between 2 and 4, but that's not accurate enough. We need consecutive integers, which means 2 in a row. So to make this a little bit more accurate, we know it's going to be somewhere between 0 and 2, so let's plug in 1 and see what happens. So you set up like this little mini table and kind of center it around where the vertex is. So since the vertex is 2, we're just going to jump back to the last point before that, which would be 1. So I'm going to plug in 1, and I could just plug it in right here. So 1 squared would be 1, minus 4 times 1, and then plus 2. So this comes out to be negative 1. So that would be this point right here. And then you could mirror that point over on the other side. Okay, so now we have enough points. Connect the dots. And now we'll be able to solve it. So solving means, like I said, you're looking for the x-intercept. So that's your x-intercept right there. It says if exact roots cannot be found, that's the case we're in right here. It doesn't cross right through at a certain value. And you're not going to say like, oh, it's close enough. If it's not exactly on it, like if it's not a point you got right off the table, then we say it's between two different values. So you have one right here. And that first one, you would say that it is between 0 and 1. They have to be consecutive. And then this one right here is between 3 and 4. Okay, so that is how you would write your answer for something like number 2. So make sure you've got that one corrected. Third problem, we're solving this. So this is the new equation that I'm setting up by factoring. So first thing that you have to do is you have to get everything on one side of the equation. So I'm going to keep the m squared right where it is. I'm going to add the 7m over to the other side. And I'm going to subtract the 18 over to the other side, which leaves me with 0 on the right. Okay, so first thing you need to do is factor, but more importantly, you need to solve by factoring, and that's the piece that a lot of people forgot. So set it up. We know it's going to be m times m. And when I set up the numbers that go in here, these numbers are supposed to multiply to a negative 18 and add up to a positive 7. So we know one of them is going to be negative and one of them is going to be positive. And multiplying to 18 could be like 1 times 18, 2 times 9, or 3 times 6. And 2 times 9 is going to be the way to go. 2 would be negative, and the 9 would be positive. And then when you FOIL it back out, the outside and inside terms would add up to a positive 7. So what it means to solve, which is our last step, is you take each of these factors and you set them equal to 0 individually. And then you should have like m equals when you're done. So here, if you add 2 to both sides, we get m equals 2 as one of our answers. And then here, if you subtract 9 from both sides, we get m equals 9 as one of our answers. So that's how you do the first 3 problems on the front page. If you had anything on the second page, I've got basically the same setup going on here. So this one, for number 4, you're subtracting 2 complex numbers. So obviously I changed to do different complex numbers. You're just combining like terms and just paying careful attention to the subtraction. So for our, actually I'm going to show you a quick little trick. Just write, so this one didn't have anything outside the parentheses. So you just write it like this. This one, the subtraction technically means that you have like a -1 outside the parentheses. So distribute it to the 6, so that would be -6, and then distribute it to the -2i, so that would change back to positive 2i. And then you're just going to combine like terms. So 8 and -6 would give me 2, 3i and 2i would give me 5i. And that's it. That is your complex number in perfect standard form. Okay, number 5, I changed to this problem right here. So when you're simplifying that, what you want to do is you want to look at the denominator and figure out what the conjugate of the denominator is. So since the denominator is 2 plus 3i, the conjugate would be 2 minus 3i. So you're going to multiply top and bottom by the conjugate of the denominator, no matter what the denominator is. So you multiply by the conjugate of the denominator, and then there's just going to be lots of FOILing that'll be happening. So we're going to FOIL out these 2 pieces of the numerator. So first would be 3 times 2, which is 6. Outside would be 3 times -3i, and that would be -9i. Inside would be -i times 2, that would be -2i. And then last, -i times -3i, that would go to a positive, and then the I times I would be I squared. Don't forget about the I squared if you're multiplying an I times I. In the denominator, same thing. We're going to be FOILing this term by this term. So 2 times 2 is 4. 2 times -3i would be -6i. 3i times 2 would be positive 6i. And 3i times -3i would be -9, and then we would again have an I squared. Don't forget about that I squared. One thing I saw people doing wrong, people were trying to cancel or simplify these. You can't do that, not when it's part of a polynomial, like a bunch of terms added together like that. So oops, so you cannot do that. One thing you can do is like these cancel out, because when you add them together, they would just go to 0. Next thing I want you to do, here's a big important idea. Every single time you see an I squared, replace it with -1. So that's what we're going to do here. So we've got 6, And then the negative 9i and negative 2i condense to a negative 11i. And then this I squared is going to be replaced with a negative 1. So we have 3 times negative 1, which would be negative 3. And then in the denominator, we have 4. Our inside terms canceled each other out. And then again, this I'm going to replace with a negative 1. So I have negative 9 times negative 1, which would be positive 9. So let's keep cleaning up. We have 6 minus 3 is 3, minus 11i. Our denominator ends up being a 13. And then for your very last step, because you need it to end up in this form, for your very last step, you would just divide each piece by 13. So 3 divided by 13 would be like your real part, like that. And then negative 11 over 13 times I would be your imaginary part. So just separating them each over the 13. Okay, so that's the imaginary number stuff. We're through 4 now, so we're about halfway done. Then we move on to our 5 problem. So we're solving now this equation by completing the square. So the very first thing you do when you're completing the square is you take whatever number is right here and you either add or subtract it over to the other side just to move it out of the way. So we're going to have x squared minus 2x, and I'm going to subtract this 4 over here to get it out of our way. Okay, that's always the first step. Second step is you take whatever number is right here. First you cut it in half, and then you square it. So when you take half of negative 2, that's negative 1, and then you square it, which would be positive 1. So you take that number that we just mentioned, and you're going to add it to the left to complete the square, but to keep the balance, you've also got to add it to the right. Okay, and then next thing we do is we're going to factor that left-hand side down. So we know it's going to factor down into this form. So the trick is like x times x will give us this x squared. Whatever number goes right here, it's half of this number, but it's also the square root of this number. So we're trying to figure out what number multiplies by itself to give us 1 and also adds to itself to give us negative 2, and that would be a negative 1. So this is really like x minus 1, x minus 1. That's how this factors down. And then on the right-hand side, I have negative 3. Okay, next, we're trying to get x by itself, so we would square root both sides. So let me continue this up here. So this is now just x minus 1 because the squared and the square root canceled each other out. On the right-hand side, I always start with a plus or minus, unless this is a 0, but it's not. So with the negative number, I know I can pull out that imaginary unit I, and then the square root of 3 does not simplify any further than that. So I just leave the 3 under the square root. And then last, just to get x by itself, I add the 1, so I have that positive 1 that I just moved over, and then plus or minus the imaginary unit times the square root of 3. And that's how you complete the square. Okay, so that's 4-5. Our next problem is from 4-6, and this is the quadratic formula. So we start with the discriminant. So a handful of you seem to not know what the discriminant was. That formula is b squared minus 4ac. So it's just the part of the quadratic formula that's under the square root. All right, so b squared, we take this middle term, negative 7, and square it. And then minus 4 times a, which is this leading term here. So that's 2. And then times c, which would be this constant, negative 4. So we're going to simplify that up. So if I square negative 7, I get 49 minus, and then 4 times 2 is 8, times negative 4 would be negative 32. So that changes to plus 32. Okay, so this ends up being 81. Okay, so that would be what we get if we simplify the discriminant. So for part A, your answer should just be a number like that. Just whatever the discriminant is. It shouldn't be under a square root. You shouldn't finish the quadratic formula. It's just whatever number you get from this formula right here. Describe the number and type of roots. So the number of roots, it's either 1 root or 2 roots. If this is anything other than 0, you're going to have 2 roots. If this turns out to be 0, then you only have 1 root. But that's the only time that it would be 1 root. Every other time it's 2. And then the type of roots. Your options are rational, irrational, and complex. If this number is negative, it's complex, because that means you have a negative under the square root. That means you have the imaginary unit I, and that turns it into complex numbers. If this is a perfect square, like this, then they would be nice, neat, rational answers. So that's the case that we're in here. The reason they're rational is because when you take the square root of 81 comes out evenly, so they're going to be these nice, neat answers. If this was positive, but it wasn't a perfect square, then these would be irrational answers, because you wouldn't be able to simplify the square root any further. Okay, last we're going to find or use the quadratic formula. So let me just write it just so you have it in front of you. If you don't have it memorized or didn't before the test, now's the time. So that's your formula. So for us, we have x equals, so the opposite of b. So b is -7, so the opposite would be +7. And then the square root of b squared minus 4ac, we just found that here. So all you have to do is just put the 81 right there. You don't have to calculate it again because we just found it in part A. And then over 2 times a, so for us that'd be 2 times 2, which is 4. So keep cleaning up as much as you can. Square root of 81 is 9. So I can simplify it up. So I would have 7 plus 9, which is 16, divided by 4 is 4. And then 7 minus 9 would be -2, divided by 4 would reduce down to -1/2. So those are my exact answers that I came up with for part C. All right, so that is the 4-6 stuff. Next, we've got 2 examples from 4-7. So this first one, actually 8 and 9 were I think like some of the biggest issues on the test. So make sure, especially if you need to see these ones, that you're paying careful attention. So when we tell you to write it in vertex form, the form that you are looking for is this. So make sure you know that form, especially know how to get it into that form. So first thing we want is A. So A here is 3. So we're going to start by pulling that 3 out. So that means factoring it from the other terms that you see here. But we're just going to take it out of these 2 terms right here. This +5 is going to end up getting pushed off to the side, just like the constant is in this actual form that we see. So 3 gets factored out. So when I factor it out here, I'm left with just an x squared. And then don't forget to factor it out of this term as well. A lot of people are missing that. So factor it out of the -12x, and that leaves you with -4x. All right, and then we're just pushing the +5 off to the side. So that's like our first step. It looks like we really haven't done much yet, but we started to get it closer and closer to this form. So like we now know that A is 3, and then our next step is to get this form out of what we're starting with here. And that's where completing the square comes in. So you're gonna do the completing the square step, just like we just like we did with number 6 when we did the completing the square problem. So we start with this middle number right here, not this number. It has to be the number after you factor something out already. So we start with this number right here. So that's -4. We take half of that, which would be -2, and then we square it. So when we square the -2, we get 4. So we are going to take that 4 and just add it in. All right, so this is now a +4. So that's the number that completes the square. So we know now that we added that +4, we're going to be able to factor it down into this form. So we had to do that. We had to add that 4 in order to be able to factor it down into this form. Okay. The problem is we just added something into our equation that didn't used to be there. So when we did that, we changed the equation. Now we're not trying to make it a different equation. We're just trying to put it in a different form. And I know that distinction is confusing, but when I added that 4, I totally changed my equation. If I were to graph this and graph this, they wouldn't be the same. So what I need to do is I need to find a way to undo, sort of, or like balance out what I just did. So I added in this pink 4 right here, but technically it was 4 times 3. Because if I were to redistribute this 3, it would technically be 4 times 3, which is 12. So what I did, there didn't used to be a 12 in my equation. I added it so that I could get this into this form. So no worries, I added 12. All I have to do is subtract 12 from the end, and it's like it never happened. It needed to so that I could get it into this form, but all I have to do is just balance out. So figure out what this is right here, and then just tack the opposite onto the end. So final steps. This can now factor down into this form. So I know it's going to be, a squared form like that. And this is now -7. So this, remember how my factoring goes? X times x gives me x squared. And I know it's supposed to be in this form anyway. And then the number that goes right here multiplies by itself to give you 4 and adds to itself to give you -4. And that would be a -2. So that's our vertex form. So you need to go through that process in order to actually write it in vertex form. And then it says, then identify the vertex. So the vertex is just an ordered pair. And it's always, for x, it's the opposite of what you see right here. So instead of a -2, it's a +2. And then for y, it's always the number that you see right here. So that would be a -7. So don't forget to identify the vertex as well. That'll lose you a couple points if you don't. Okay, so 8 was one of the hardest ones. I think 9 was one of the hardest ones as well. So these are transformations. This is in vertex form, the same exact form that we just came up with here. So we have 3 old points, so over old or original. Oops, 0. So you need to know these 3 points, and then we're going to work on transforming them. So let me show you what the 3 different values do. So whatever value right here is called A, and that's A from our form right here. So what A does is you're supposed to multiply the Y values by A, okay? Next would be this right here. So you have X plus 2, so that's your H. So remember with X, since this is like X minus, you always do the opposite of what it looks like you're going to do. So when I see X plus 2, I do the opposite and I actually subtract 2 from my X values. And then this number right here affects the Y and does what it looks like it's going to do. So I add 4 to the Y values. So repeat myself again. What I have underlined right here, that affects the X values. It's the only thing that affects the X values, and it does the opposite of what it looks like it's going to do. Okay, so when I see X plus 2, I actually will subtract 2 from all of my X values. So to get my new points, this original X value is -1. But I'm going to subtract 2 from it, so now it'll be -3. This original X value is 0, but I'm going to subtract 2 from it, and it'll become -2. And this original X value is 1, but I'm going to subtract 2 from it, and that'll make it -1. Okay, then with the Y's, I told you that anything outside the parentheses will affect the Y value. Make sure you do the multiplication first and then the addition. So you're going to be taking these Y values right here. First, you're going to multiply them by -1, and then you're going to add 4. Okay, so start with 1, the original Y value. First, multiply it by -1/2. I'm sorry, I said -1 before, -1/2. So take 1, multiply it by -1/2. That gives you -1/2, and then add 4. So -1/2 plus 4 would be +3.5. And then move on to the 0. So here's your original Y value. First, you multiply it by -1/2, which is still 0, and then you add 4, which should be 4. And last Y value, start with 1. First, you multiply it by -1/2, which should be -1/2, and then you add 4, which should be 3.5. So once you figure out how the transformations work, you just take these 3 points and plot them, and then that's it. That's your graph. So we have -3, and then up to 3.5. So 1, 2, 3.5, like right there. -2, 4 would be -2, and then up to 4 right there. And -1, 3.5. So like right in the middle there again. So you plot your 3 points, and then to graph the function, you just connect the dots. And that's it. So really important to remember, don't change it out of this form. You just need to know how to transform these 3 original points like I just did. Okay, so that's 4, 7. I think 8 and 9 were probably the hardest ones, or the ones that people had the hardest time with, I guess. Number 10 was from 4, 8. This one, you graph it almost identical to what you do in number 1. Just make sure that you're paying attention to this symbol right there, because that will tell you if you have to have a dashed line, and it will tell you where you shade. So the only difference between number 1 and number 10 is that you'll have some shading, and you might have a dotted line. And here we will, because it's just a greater than. So same setup as we did with number 1. So we start with our axis of symmetry, which will be -b/2a. So the opposite of b would be +4. And then over 2 times a, so 2 times -2 would be -4. So this is -1. So go ahead and start sketching in your axis of symmetry right there. Then we want to know where the vertex is. So you're going to plug -1 into this function right here. Okay, so here, remember a big trick, make sure you're squaring first and then multiplying. So when I square the -1, I get +1. Then I multiply it by -2. And then here, negative times negative would be +4 plus 2. So this comes out to be 4. So that is the y-coordinate of my vertex. So this, like the x-coordinate is -1, and the y-coordinate is 4. So that point is going to be my vertex, which will be right there. And then last little piece to actually graph it, I always need the y-intercepts. 0 is always the x-coordinate for the y-intercepts, and if I plug in 0, I end up just with 2. Okay, so plot that. That would be right there. For a third point, I'm just going to mirror this over on the other side of that dotted line. And then I just need to graph and then shade. So connect the dots, make sure you're using a dashed line though. So connect the dots using a dotted line. If you forget to do that, just make me a note. And then last thing, I'm going to test the origin to see where I should be shading. So plug in 0, 0. So I want to know, is 0 greater than, this would be 0, this would be 0, and you'd be left with a 2. So 0 is not greater than 2. So that means that 0, 0 is not part of the shaded region, and 0, 0 is kind of inside the parabola, so we shade everything outside of the parabola. All right, so that's your first 4-8 problem. Our second to last problem was the other one that we have from 4-8, and then I'll walk you through how to do the bonus as well. So this, you first start by factoring. So we're going to factor x times x, and then, so we're multiplying to -6 and adding to -1. So to multiply to 6, it could be 1 times 5 or 2 times 3. So to multiply to -6, one of these has to be negative and one of them has to be positive. And then to get -1 in the middle, it would be a -3 and a +2. Okay, so we set that up. First thing we want to do is find our x-intercepts. And we find our x-intercepts by setting each of these equal to 0. So set x minus 3 equal to 0, and set x plus 2 equal to 0. Okay, so this one we end up with x equals 3, and then this one we end up with x equals -2. So set up a number line. Always make sure that you have your number line set up here so you can do your little true-false sign chart. So in numerical order, first would be the -2, and next would be the +3. And what we do then is, this is now split up into 3 different regions. So we want to test, is this region true or false if I plug it in? Same with this one, same with this one. So here we could test a value like, I don't know, -10. So we want to test -10, and we're just going to plug it in here. So if I square -10, I get 100, minus -10, minus 6. We want to know if that is less than 0. It definitely is not, so that would be false. If I plug in something between -2 and 3, 0 is our easiest option here. So if we plug this in, 0, minus 0, minus 6, we want to know if that is less than 0. So this is just -6, and yes, -6 is less than 0, so this region is true. And then finally something bigger than 3, like 4. You can test anything just as long as it falls in, each region. So testing 4, if I square 4, I get 16, minus 4, minus 6. And finally, we want to know if that is less than 0. So this comes out to be, 8? No, 6. And that is not less than 0 either. So that region